Welcome to the NJIT website and math podcast. My name is Vanessa. Today I will be covering solving linear equations. So solving linear equations is one of the few basic skills that you need in algebra. It can range from solving very simple equations to something that's very more complex with fractions and exponents and parentheses. But the good thing is that it's all based on very basic arithmetic skills. So if you can master those skills, then you'd have no problem solving linear equations, and that can transcend into solving quadratics, cubics, or any number of polynomial equations for a variable. So let's just go over some of the basic concepts that you need in order to solve any kind of linear equation. And that is just to remember pen mass and the basic rules for any equation. So pen mass, if you don't remember, the acronym for it is PEDM, addition, subtraction. Okay, so the P is for parentheses, exponents, multiplication, division, addition, and subtraction. So this is basically the order of operations in which you use to solve any equation. It's always good to keep that in mind. The other pointers that I would recommend before diving into this is, first off, I would always remember is to solve parentheses. Now what I mean by that is sometimes you'll have factors that are outside of parentheses. The best thing to do is to distribute that factor outside of the parentheses into the parentheses and then collect any like terms before proceeding with order of operations. Second pointer I would give you is to eliminate fractions by least common denominator. As most people don't like to deal with fractions, and at the end of the day it just makes your equation a lot more complicated, the best thing to do is to get rid of the fractions from the very beginning by multiplying the whole thing by least common denominator. And I will make sure to do an example like that. So let's dive right into it and just go over some examples. So let me start with a very simple basic equation. We've got the formula here, 2x plus 3 is equal to 5x plus 1. Okay? We don't have any parentheses, no exponents, so simply now it's just order of operations mixed in with the most logical and effective way to solve a linear equation. Now don't forget our main objective with this. Our main objective is to find our objective variable, get it, isolate it, or get it by itself on one side of the equal sign, get everything else on the other side of the equal sign, and that way we can just solve for that variable and get it by itself and eventually get an answer for it. So in this case, in this example, our objective variable is x. That's what we're solving for. So our goal is to get x by itself, not multiplied by any numbers, not having anything added onto it or subtracted by it. So the first thing we want to do is let's do that. Let's get x on one side of the equal sign, because as you can see we have a 2x on the left and a 5x on the right, and we want to get it on one side. So let's do that. Let's get the x only on the right side of the equation. Now don't forget that whenever you do any kind of operation, whether it's addition, subtraction, multiplication, and division, whatever you do to one side of the equal sign, you need to do to the other side of the equal sign. And let me repeat that because I can't emphasize it enough. Whatever you do to one side of the equal sign, you must do it to the other side of the equal sign in order to balance the equation. Kind of like chemistry. So what I'm going to do is I'm going to take the 2x on the left and shift it over to the right. Now, if there's no sign in front of the 2x, that automatically implies addition. So if you want, put a little imaginary plus here. So if there's a plus, in order to move it over, you have to do the opposite operation. So the opposite operation of addition is subtraction, so we're going to subtract 2x. So again, you have to do it to both sides of the equation. So I'm going to subtract 2x here and a 2x here. As you can see on the left side, 2x minus 2x cancels out. And here we have 5x minus 2x, which gives us a 3x. And then everything else we just bring down. Okay? So now we have x on one side of the equation. But however, we have the plus 1 on the right side as well. So we need to move that to the other side. So because there's a plus in front of it, we do the opposite operation, which is subtraction. So we're going to subtract 1 on both sides. On the left side, we have a 3 minus 1, which is simply 2. The plus 1 minus 1 cancels out to 0. And then we just bring everything else back down. Okay? Alright, so we have no additional terms on the right side of the equation next to the x, but the x is being multiplied by 3. And we can't have that. We need to have the x completely by itself. So a 3 times an x is clearly multiplication, so the opposite operation would be division. So we're going to divide both sides of the equation by 3. So we're going to divide by 3 here, and divide by 3 here. 3 over 3, please be careful. For the addition and subtraction, we've been doing plus or minus, which cancels out to be 0. When here, 3 over 3 does not come out to be 0. It cancels out to be 1, which is what we want. Write a little 1 there. And then here we just simply have the fraction 2 over 3. So at the end of the day, our answer, here we have 1 times x, which is perfectly acceptable because that just makes x by itself. X is equal to 2 over 3, which is our final answer in this case. Okay? Easy enough. That was pretty much a basic linear equation example. So let's up the ante a little bit and do something a little bit more complicated. This time let's do something that involves parentheses. So say we have this. Let's say we have 3 times x plus 2 is equal to 4 minus x. Okay? This time we have parentheses to deal with. And as I said in the first slide, you always want to deal with the parentheses first before doing any arithmetic. So we have a 3 and in parentheses x plus 2. So what we want to do is distribute that 3 into each term inside of the parentheses. So sometimes it's good to draw little arrows to show what I'm talking about. So the 3 is going to be multiplied with the x, and it's also going to be multiplied with the 2. So let's do that. So first is 3 times x, which is just simply 3x. And then the 3 times the 2, which is positive 6, it just becomes plus 6. And then I'll just rewrite everything else. Okay? So now this just simply looks like the first example that we did, which is just you do basic arithmetic and isolate the variable. So let's do that. So what I'm going to do is I'm going to take the minus x on the right side and I'm going to move it over to the left side. Now because it's a minus in the front, we do the opposite operation, which is addition. So we're going to add an x here, and we're going to add an x here. So minus x plus x comes out to be 0, so that goes away. And then here we have 3x plus 1x, which is 4x. And we copy down the rest. Okay. An important note to make is that whether you're moving the variable or any number from the left to the right or the right to the left, either one can apply, as long as you stay consistent and do the same thing on both sides of the equal sign. Now what I mean is, in this particular example, I could have either moved the x to the left side, as I did, or I could have subtracted the 3x and moved the x to the right side of the equation. Both would give me the same answer at the end of the process, but the important thing is to stay consistent. remember, I added the x on both sides of the equation. If I was going to move the 3x, I would have to subtract 3x on both the left and the right side. Like I said, you can try it at home if you want, and essentially you'll get the same exact answer at the end. But just remember to stay consistent. Okay, so now we have the x on the left side, but now we have to move that constant 6 to the right side. So if it's addition, I will change it to subtraction and move it over. So we're going to subtract 6 here, subtract 6 there. This cancels out to be 0. This is a 4 minus a 6, which is equal to -2. And then we'll just bring the 4x down. Okay. Finally, gotta get the x completely by itself, and it's being multiplied by a 4. So in order to do that, we need to divide both sides by 4. Right? So divide by 4. Divide by 4. Alright. 4x divided by 4, it just leaves you the 4 and the other 4 cancel. So that just leaves with an x. And on the right side we have a -2 over 4, which you could leave as a fraction, but it simplifies to -1 over 2, right? Because both sides are divisible by 2. So if you want to do the little intermediate step here, I will do that. Because you can divide both sides by 2, divide by 2. So then that makes this a -1, and then this makes that a 2, right? Okay, and then I'm going to bring down the x here, and there you go, we have our answer. Our final answer is x is equal to -1 over 2. Okay, so now we're going to do one more example, and we're going to make it a little more tricky, even more than this one, by throwing fractions in from the beginning. Now remember what I said in the beginning, that we want to eliminate the fractions from the very beginning. That way, as the problem goes on, we don't have to deal with fractions anymore. Okay, so our final example is going to look something like this. 2x plus 1 over 9 minus x plus 4 over 6 is equal to 1. Okay. Don't be scared by the fractions. They're not that big of a deal. So, first thing we have to do is, we see our denominators are 9 and 6. We need to find the least common denominator that can eliminate both these numbers. So, if you go back to your math class, the least common denominator that the 9 and the 6 have in common would be 18, right? 9 times 1 is 9, 9 times 2 is 18, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. So that's the first number that they both have in common. So we're going to multiply both the whole equation, both left side and right side, by 18. So let's do that. Oops, sorry. Oop. Okay, 18, and I'll put the 18 over here as well, so you remember. Okay, so now it just becomes like the distribution of the parentheses. This 18 I'm going to distribute here and here, and then this 18 is just going to go here. Okay, so let's do it one piece at a time. The 18 times the first portion, if you do it light, I'm going to do it lightly here. As you can see, the 18 and the 9 can cross cancel. So the 9 becomes a 1, and this becomes a 2 because the 9 goes into 18 two times. So now it's just 2 into 2x plus 1, which I will rewrite down here. And because the 9 became a 1, we don't even need to rewrite the denominator anymore. Okay? So now we're going to do the same thing with the second term. I would always rewrite that minus sign from the beginning. That way you don't forget it, because sometimes the biggest mistake you can make is to forget a negative, which will throw your entire answer off. So let's do it again. Let me rewrite the 18, because don't forget the 18 is still an 18 for that second term. So the 6 will go into 18 3 times. 6 goes into 6 once. So let's see. It becomes a 1. This will become a 3 in this case. So then that 3 will distribute into the rest of it. So it'll be a 3 times x plus 4. Okay? Now let's do the last term on the equals after the equal sign. 18 times 1, which is simply 18. Can't do anything with that. Okay? So now it became kind of like the second example that we did, where we have just parentheses and numbers that we have to distribute back in. So let's do that. For the first term, we have the 2, which needs to go into the 2x, and the 2 that needs to go into the 1. So 2 times 2x is 4x. 2 times 1 is 1. I'm sorry, 2 times 1 is positive 2. Excuse me. Now let's do it for the next one. Now it's a negative 3 that we have to distribute in. Don't forget the negative. So this 3 is going to go into here and here. Minus 3 times x is just minus 3x. Minus 3 times a positive 4 is minus 12. And on the right side of the equation, we just have to rewrite the 18. Okay? Now before I start moving things between the left and the right side of the equal sign, you want to always collect like terms on the one side if you have many common terms. Like here we have the 2 and the minus 12 that can go together, and then the 4 and 4x and the minus 3x that can go together. So let's bring them together. So we have a 4x minus 3x, which is just 1x. And then we have the 2 minus 12, which is minus 10. And then on the other side we just have 18. Alright, so the x is already, it's not multiplied times anything, so we don't have to divide anything. Only thing we have to do is take that minus 10 and move it over. So we're going to do that by adding 10 here, adding 10 there. The minus 10 and the plus 10 will cancel each other out. And then 18 plus 10 is 28. And then we'll bring down the x because there's nothing else to bring down. And there we go. Final answer, x is equal to 28. And it's that simple. See, it's very systematic. Just go back to your basic steps and then the pointers that I gave you, and you should have no problem solving linear equations. So thank you so much for visiting the NJIT website. If you need any further assistance, stop by the Center for Academic and Professional Enrichment, also known as the CAPE, in Koopvrien Hall, room 200, and good luck in your studies.